Let us come back and do the 2015 paper, right? So 2014 we have certain reasoning questions. Please practice those reasoning questions. Only thing is, for 1 mark you can write 2 reasons and finish off your answer. So let us see this 2015 paper. Such reactions are very easy for us to solve, isn't it? Right. What do they give us? They've given us ketone, they've given us hydrogen cyanide. I have to show the nucleophilic addition reaction. So as soon as you see hydrogen cyanide, first important thing, try to shift the bond here, oxygen. So this becomes minus, this becomes plus. My work is done. Here, come back and divide hydrogen cyanide into plus and minus. Now we very well know the positive charge goes and attacks the oxygen, and the negative part goes and adds to. How do I get? You get CH3, pick up this carbon, your oxygen is with H plus now, your methyl group is down, and your CN is above. So what is this called? This is called, we have got it from acetone, isn't it? This is your acetone. So this is called acetone cyanohydrin. That's it. Simple. Well, let us come back and see the next reaction. Here, what do they give us? They've given me ethyl benzene, right? Now, I always said, whenever you find KMnO4, right? So simple, KMnO4, if you given directly, you can convert it into the potassium salts and then benzoic acid. So most of the reactions you can stop it there, where you can stop it like formation of potassium benzoate, but here they've given me H plus. So you have to write both the steps. What am I trying to explain? What did they give me? Ethyl benzene. So this is an oxidizing agent. So what should I do? Oxidizing agent has to first convert, irrespective of the alkyl chain, it's going to convert it into potassium benzoate. So let us write, it is potassium benzoate. After that, they said this is attacked in the presence of H plus. So this is going to come and attack this bond. Yeah, and what do you get? You get benzoic acid. This is your benzoic acid. Right, so done. Let us come back and do this. We have already done this reaction also. So whenever your acetaldehyde is given to you, try to write like this so that it is easy for you to add ammonia. What should you do first? As I said, shift. This becomes minus, this becomes plus. NH3, again you are going to cleave that also in this way. Okay, yes, this becomes plus, this becomes minus. Yeah, now shift. Your minus comes in, attacks carbon, your H comes in, attacks oxygen. What do I get? I get CH3, your carbon is here, hydrogen is still here, your oxygen has the H and your NH2. Right, acetaldehyde or acetaldehyde amine adduct. We have added amine product, right? Now what are you going to do? You're going to warm this reaction. When you're warming this reaction, observe one H from here or one OH from here, this complete OH, and one H from here, okay, one H from here gets eliminated when you're warming it. Then what happens? The bond which is present here, okay, this is coming out with this bond which is coming out as water, and this is going to shift here. This will shift here. What do you get? You get CH3, CH, double bond NH, because one H is already gone with this water, OH is already gone. Now this is your compound. What is this compound? This has come from acetaldehyde, isn't it? And this is imine. So acetaldehyde, NH is imine, acetaldehyde. Okay, this is your compound. Just go through, it's very easy. Important thing is only your practice. Practice makes man perfect, we said. So practicing organic reactions is the most important criteria. Right, let us come back and see the part B question of your 2015. Basically, we have done the 3 marks question. We are left for two more marks. The chapter is for 5 marks. So let us see this question. They've asked us to write the reagents in the following reactions. Now, whenever such questions are given to you, right, either I said they may give you the reactant and ask you to write the products, or they may give you the product and ask you to write the reactants, or they may ask you to write the reagents. Now, when you see such type of reaction, just observe how many carbons do we have here? 1, 2, 3. In the product, how many do we have? 1, 2, 3, 4 extra. Then other than oxygen, this is here you have OH bond. Now what happened here? There is, when you see, there is an addition of an extra carbon chain. How many here? 1. If I take out this 1 and 2. Here 1, 2, 3, correct? Then extra carbon chain, isn't it? One carbon chain has got added to that. So which will get me that carbon chain? Grignard's reagent. So I can use Grignard's reagent with which, how many? Already 1 and 2 are here. 1 and 2 are here. This carbon is here and this extra. So to get that Grignard's reagent, CH3 MgBr in dry ether. That is important. Dry ether. And the second one, you are going to further hydrolyze it. Then only Mg comes out as MgOHBr. I've already done this reaction with Grignard's, addition of Grignard's reagent to aldehydes and ketones. What's that video? You will understand what am I trying to explain. So both after addition, you are going to do hydrolysis also. This is important. So these two are the reagents. Even if you're not writing one reagent, you'll lose half mark for that. Now let us come back and see. Acetic acid to monochloroacetic acid. What are you finding? One hydrogen got replaced by a chlorine. So there should be something to get this chlorine to me. So that this chlorine gets added to this hydrogen and HCl comes out. That is what. So what is the reagent? I can easily use chlorine in the presence of phosphorus. I feel this is the easiest example. So this chlorine, one chlorine goes and replaces the alpha hydrogen. That hydrogen comes out as H plus and I am going to get monochloroacetic acid. So we have also seen one reasoning question. Monochloroacetic acid is highly acidic than as normal acetic acid. Dichloro is highly acidic than mono. Trichloro is more acidic than dichloro, right? So these are your reactions. So let us meet again with 2016 paper.